When we're thinking about confounding, we're often talking about some variable that is causing us to get a biased result. And when we control for that variable in whichever way we decide to control for it, we find that it's often a possible alternate explanation for an observed association. And after you control for that variable, oftentimes that association can go away. Regardless of the way that that variable biases your results, you can get what we call negative confounding, or you can also get what we call positive confounding. Now remember, when confounding is present, the unadjusted measure that you calculated, it wasn't valid. It was a biased measure. So that crude or that unadjusted measure of association, if you have confounding present, that measure is biased. It's not a true or accurate measure in terms of the relationship between two variables. So when you have that confounding present, when you have that bias present, it is going to cause either negative confounding or positive confounding. So when we're talking about negative confounding, we're looking at that crude odds ratio, which is a biased measure of association. We're looking at it compared to the adjusted measure of association. So if that crude measure is closer to 1 compared to that adjusted measure, then we would conclude that we have negative confounding. If that measure is further away from 1 compared to that adjusted measure, then we have positive confounding, meaning that the confounding that was present in that crude measure was causing us to overestimate that measure of association. Let's draw this out to kind of visually show what we're talking about when we mean positive and negative confounding. So let's say that our null hypothesis is right here. Our measure of association, regardless if it's a relative risk or an odds ratio, let's say it is 1, meaning there's no association between our variables. Let's say that I calculate my crude measure of association and I get 3. Well, let's assume that we actually have confounding present in our study and that whatever variable or variables we looked at were confounders in that relationship, and we calculated an adjusted odds ratio. We found that that difference was greater than 10% and determined that, yes, we in fact do have confounding present. That means that this crude measure is a biased measure of association. It is not the best measure that we should be using to quantify the relationship between our variables. So let's say that this is our biased measure of association, our crude measure, and let's say that we calculate our adjusted. This adjusted measure is going to be a much better measure. It's going to be a more valid measure of association between our variables of interest. When we have negative confounding, what happens is the presence of confounding caused us to calculate a measure that underestimated the strength of that relationship. So remember, this is a biased measure, and when we calculated this, we only got a measure of 3. But after we adjusted for the confounding and accounted for that in our study, we got a more valid measure of association, which actually shows that the odds ratio or the relative risk, regardless of which one you're using, it's actually 6. So we see that this confounded, this biased measure that we saw originally, it caused us to underestimate the strength of the relationship between our variables. Now, right now we're on this side of 1, but you can get the same issue on this side of 1. So let's say that we calculated a crude measure of association of 0.7. Let's say that we calculated an adjusted measure because we have confounding present in our study. Remember, this crude measure, this is going to be a biased measure of association. This adjusted measure is a much more valid measure of association that we should use. In this particular scenario, what we saw was that this crude measure, it indicated a protective association, but it's not that protective. In fact, when we look at that adjusted measure, which is the measure we should be using given that we have confounding, this measure actually says, no, your relationship between your variables, it's actually super protective. So this biased measure caused us originally to underestimate the strength of the relationship. Let's take a look at positive confounding. So positive confounding is essentially the different complete opposites of negative confounding. So let's say, for example, we calculated a crude measure of 6. Let's say that that crude measure is a biased measure because we have confounding in our study. So then we look at our adjusted measure, and what we see is this original crude measure, this was a biased measure. It looked like there was a really strong positive association, got a measure of association of 6. However, when we adjusted for that confounder that ended up actually being a confounder, what we found was that our measure of association actually dropped down to 3. So this is the more valid measure that I would report for my results. The presence of confounding, when you have positive confounding, it causes us to observe a measure that is actually overestimating the strength of the relationship between the variables in our study. We can get the same issue on the other side of 1 as well. So let's say that I calculate a crude measure of association of 0.2. Remember, this is a biased measure of association. And so when we look at that adjusted measure, we actually see that the more valid measure is 0.7. What this indicates is that originally with this biased measure of association, this causes to originally think that this relationship among these variables had a really protective relationship. However, when we adjust for that confounding, we see it's still protective, but it's actually not that protective. So again, the presence of confounding, when you have positive confounding, it causes you to see a biased measure of effects that overestimates the strength of that relationship.